Imagine a star sitting about 1,470 light years away from us. It's in the constellation Cygnus. And you're monitoring its brightness, and suddenly, just inexplicably, it dims.
And we should clarify, it's not dimming by just a tiny fraction of a percent, which is what you'd normally expect.
Right, exactly. It dims by up to 22%, which, to put that into perspective for you, if a planet the size of Jupiter crossed in front of this distant star, it would only block about 1% of its light.
Yeah, 1%.
So whatever's out there blocking our view, it's roughly half the width of the star itself. It just completely defies everything we know about planetary physics.
It really does. I mean, when dealing with an F-type main sequence star, a 22% drop in luminosity basically breaks all our standard models.
Because an F-type star is supposed to be stable, right?
Exactly. It's a stable, middle-aged star. It's hotter and more massive than our sun, fusing hydrogen into helium at a very steady rate. A star like this should burn reliably for billions of years.
It shouldn't just be flickering wildly in the dark.
No, absolutely not.
Okay, let's unpack this, because that anomaly is the core of our deep dive today. We're looking at KIC 8462852.
Right, formerly known as Boyajian star.
Yeah, after the lead astronomer. But, the internet and the media, they know it better as Tabby star, or, honestly, my favorite name for it, the WTF star.
Which officially stands for, where's the flux?
Right, officially. But we all know what they really meant.
Yeah, astronomers naming it the WTF star really tipped their hands to just how baffling this data was.
So the mission of this deep dive today is to really get into the mechanics of this mystery. Because this isn't just about a weird blinking light in the sky.
No, it's a story about the limits of human knowledge. It's about the power of citizen science, and really how a single anomaly forced the mainstream scientific community to genuinely test the hypothesis of alien megastructures.
Which is wild. So to really grasp the absurdity of that 22% drop, think about standing on a dark sidewalk looking at a distant streetlight. If a moth flies by, it barely dims. But if a truck drives by, the light goes completely dark.
That's a great way to picture it.
Thanks. So what we're seeing here is basically a truck-sized shadow passing by in a place where only moths should exist.
Yeah, and to understand why a shadow that large just shouldn't be there, we have to look at how we normally find exoplanets.
Which brings us to the Kepler Space Telescope, right?
Right. So Kepler operated from 2009 to 2013, and it just stared continuously at a single patch of sky. It monitored the light curves of over 100,000 stars simultaneously.
Just looking for tiny little dips in the starlight.
Exactly, using the transit method. It was looking for highly predictable, periodic dips. So if a star's brightness drops by like 0.something% every 365 days like clockwork, boom, you have strong evidence of an exoplanet.
But the algorithms processing that Kepler data, they were programmed to find mathematical certainty. Neatly repeating patterns. Yeah. They were not looking for chaos.
No, they'd filter that out as noise.
Right. And that is why it wasn't some NASA supercomputer that found the WTF star. It was everyday people.
Citizen scientists.
Yeah. People just logging onto the internet for a crowdsourced project called Planet Hunters.
Which is so cool because Planet Hunters let volunteers look at the raw light curves from Kepler. Just these line graphs showing brightness over time.
Yeah.
And human brains have an evolutionary advantage over algorithms when it comes to visual pattern recognition.
Especially for spotting things that are just irregular or weird.
Yeah, and the citizen scientists flagged it because the graphs just looked entirely wrong.
I mean, we're talking massive chaotic events. March 2011, a 15% dip. Then get this, 726 days later, in February 2013, that massive 22% dip.
And then another 8% dip just 48 days after that.
Just totally random. So if Kepler is looking for repeating patterns to prove an orbit, what do these random dips actually tell us?
Well, the periodicity, the fact that there's no rhythm, immediately ruled out a standard planetary orbit. Planets are bound by gravity, so they travel on regular schedules.
They'll just show up whenever they feel like it.
Right. These dips were erratic, asymmetrical. So a gas giant or a rocky world was completely off the table.
And when you take the safe, normal explanations off the table, scientists are forced into some really fascinating, weird territory.
Yeah, you have to start entertaining ideas that sound like pure science fiction.
Which brings us to Jason T. Wright, the astronomer who basically made global headlines by suggesting, wait for it, the Dyson Swarm hypothesis.
Yeah, the alien megastructure.
So for anyone who doesn't know, a Dyson swarm is this concept where an advanced alien civilization builds an artificial megastructure around a star to harvest its energy.
Right. Imagine millions of massive solar panels or orbital habitats just swarming around the star, and occasionally they group together and block out massive chunks of light as they pass our telescopes.
Okay, but I can hear the scientific community groaning from here. Like, Occam's razor says the simplest explanation is usually the right one, and aliens are rarely the simplest explanation.
Yeah, true. The scientific method demands you exhaust every natural explanation first. But the thing is, the natural models had failed to fit the Kepler data.
So it actually became a valid, falsifiable hypothesis.
Exactly. It was falsifiable because if there's an advanced civilization harvesting energy, they would leave a detectable footprint. They'd emit radio waves or lasers or, crucially, waste heat.
So SETI, the search for extraterrestrial intelligence, they jumped on this immediately. They pointed the Allen telescope array at the star to look for radio emissions.
And the Veritas Observatory looked for ultra-fast, nanosecond optical flashes.
They even had an automated planet finder looking for a specific 24-megawatt laser emission. But the result of all that scanning, just dead silence, no radio signals, no lasers.
Nothing.
But wait, is it possible we were just looking for the wrong kind of tech? Like, a civilization that builds a Dyson Swarm probably isn't using a ham radio.
That's a fair point. We can only search for tech we understand, but there is a deeper physical law here that you can't escape, which is thermodynamics.
The waste heat.
Right. Any machine doing work produces waste heat. If a Dyson swarm is absorbing all that stellar energy, it has to radiate mid-infrared energy back into space.
So they checked the Spitzer Space Telescope since it looks for infrared heat.
Yep. And they found absolutely zero excess infrared radiation.
Wow. So it's not just the radio silence. The lack of heat means there's no machine up there. Thermodynamics basically killed the alien theory.
It really did. And this lack of infrared heat, combined with the silence, forced astronomers to look much closer at the star's deep history. They needed to know if this was just a weird modern fluke or part of a long-term evolution of the star.
And this is where the investigation takes this wild historical twist. To figure out what the star was doing today, astronomer Bradley Schaefer dug into the archives at Harvard.
He pulled out a century's worth of glass photographic plates.
Yeah, from 1890 all the way to 1990.
Which is just agonizingly difficult work. You're looking at fragile, degrading emulsions with magnifying tools, trying to measure a tiny dot of light to figure out its historical brightness.
While adjusting for, like, different cameras used over 100 years.
Exactly.
But Schaefer's analysis showed that over that century, Tabby's star had gradually faded by about 20%.
Unprecedented for an F-type star. They should be completely stable. And then another study found it had a 0.34% annual fade right before taking a rapid 2.5% drop.
So it's having these violent, massive, short-term shadows and bleeding out its brightness decade after decade. But right at the peak of the mystery, around 2013, the Kepler Space Telescope broke.
Yeah, 2 of its reaction wheels failed.
So they lost the ability to point it precisely. The whole astronomical community was suddenly blind to the most mysterious star in the galaxy, right when they expected another dip in 2015.
And telescope time on other major observatories is incredibly competitive. It's booked years in advance. You can't just ask them to stare at one star indefinitely, just in case it flickers.
But lead astronomer Tabitha Boyajian found a completely brilliant workaround. She bypassed the grant system and literally went to Kickstarter.
She pitched the WTF Star directly to the internet.
And raised over $100,000 to buy continuous telescope time on the Las Cumbres Observatory Network. Plus, amateur astronomers were providing near 247 coverage from their backyards.
And that crowdfunding paid off spectacularly because in 2017, the star dimmed again.
The dips were smaller, right? Like 1 to 3%.
Yeah, but the difference was this time we caught them in real time. We had multiple telescopes looking at it in different wavelengths of light simultaneously.
They even gave them names: Elsie, Celeste, Scarbray, and Encore. And this is where this smoke versus brick wall breakthrough happened.
This is my favorite part of the physics here.
So if an alien megastructure, a solid object, passes in front of a star, it blocks all colors of light equally.
Yeah.
Like a brick wall. It just stops the photons.
But the 2017 observations showed chromatic dimming. The light was not blocked equally. The blue light from the star dimmed much more than the red light.
Which points to only one logical conclusion.
Really scattering. It's the same thing that makes our sky blue. Microscopic space dust filters light the exact same way. So the 2017 data definitively proved it's not a solid, opaque object. It's an immense cloud of microscopic dust.
Right. So alien megastructure is out, dust is in. But that just replaces an alien mystery with the physics mystery. Where does a cloud of dust big enough to block 22% of a star come from?
It requires a staggeringly violent mechanism. The first major natural theory to gain traction was the comet cloud hypothesis.
Basically a massive swarm of disintegrating comets.
Right, like our solar system's Oort cloud. And support for this actually came in 2021 when they confirmed a red dwarf companion star about 880 astronomical units away.
Which is, what, 30 times further than Neptune is from our sun?
About that, yeah. But its gravity could perturb that comet cloud, sending massive waves of icy comets plunging inward. And as they get close to the hot F-type star, they melt and disintegrate, leaving chaotic trails of dust.
Okay, comets make sense for the erratic dips. But what about the really violent theories? Like, what if Tabby's star swallowed a planet? Or what if it's the aftermath of two protoplanets just smashing into each other?
Those kinetic theories are super compelling, but they run into the exact same thermodynamic wall the aliens did.
The Spitzer Space Telescope again.
Yep. If you smash two planets together, the friction generates astronomical amounts of heat. You get warm dust. And warm dust glows brightly in the mid-infrared spectrum.
But Spitzer saw no excess infrared energy.
Exactly. The dust around Tabby's star is cold, which means a recent collision is impossible.
So if it's cold, it either happened a very long time ago or very far away. Which brings us to the 2019 theory. And here's where it gets really interesting. Colonics.
I love that term. It's a portmanteau of planet and moon. In formal literature, they're tidally detached exomoons.
The mechanics are wild. We think of solar systems as stable, but numeric simulations show early systems are totally chaotic. You have a massive gas giant, like Jupiter, with a huge icy moon. And as a solar system forms, the planet migrates inward.
Spiraling closer to the star, and a massive gravitational tug-of-war starts. The star's pull competes with the planet's pull on its own moon, and the tidal forces are immense.
And in about 50% of these simulations, the star wins.
Yes. The star essentially steals the moon. It violently shears it away.
An orphaned exomoon. And without its parent planet's gravity, it gets flung into this highly erratic, eccentric orbit around the star.
It's subjected to intense stellar radiation, so it begins to literally melt and break down.
Just shedding vast clouds of debris and dust, creating the exact erratic light curves we see.
It's an incredibly elegant theory. It explains the erratic shadows, the sheer volume of material needed to block 22% of the light, and the chromatic dimming.
So we are basically watching this slow, agonizing death of a stolen moon.
Yeah, it really shows how violent the early lives of planetary systems actually are.
That is just incredible. We started this deep dive looking for alien solar panels, and the science led us to the melting corpse of a kidnapped moon.
It's a perfect example of how anomalies drive astrophysics. The universe doesn't perfectly fit into the neat little boxes we build for it. What started as a search for aliens turned into discovering entirely new mechanics of planetary evolution.
And for you listening, I think the biggest takeaway here is that you don't need a PhD to make a paradigm-shifting discovery.
No, not at all.
Citizen scientists staring at public data found the most mysterious star in the galaxy just by trusting their intuition when a graph looked wrong.
It democratized astronomical discovery. Human pattern recognition is still vital.
Absolutely. And I want to leave you with one final provocative thought to mull over. There were over 100,000 stars in that original Kepler data alone. And recently, astronomers found 21 other stars acting erratically, kind of like Tabby's star.
The archives are vast.
They really are. We've ruled out aliens for this one, but what else is hiding in plain sight in that data right now? Just waiting for someone like you to log on and notice a shadow where a shadow shouldn't be.
The anomalies are definitely where the real discoveries begin.
Exactly. So next time you're looking up in the night sky, remember the WTF Star. Might not be a truck up there, but it's definitely not a moth.